All right, here we are in the answer key for Chapter 4 Quadratics. I'll go quickly, and you might need to pause me if you find me going too fast, but here it all is. Sketch the parabola based on the given equation that's in vertex form. So vertex form is where you can read off the coordinates for the vertex very easily by taking the opposite of this parentheses. That's 5. So I go over to 5, and then I go up 7. So the vertex is up here at 5, 7. It's important that you label it. It's not so important that you get it perfect. But we need another point. I know that this opens down because it's a negative, but where does it hit on the y-axis? I just plug in 0 for x. Negative 5 squared is positive 25 times negative 3 is negative 75 plus 7 is negative 68 then. So this is where you're going to rework your scale for the y. So clearly, if I need to go down to negative 68, that's going to be negative 10, 20, 30, 40, 50, 68. All right, so it's a bit crazy that way. So I'm going to move this down here. That's where 5, positive 7 is going to be. And then I just show it going down and hitting down here, and just label it. You know, it's just what you say the scale is really the important thing. So I would just make a big old dot there and label that 0, negative 68. Okay. If you wanted to sketch a symmetric point over here, that's easy. That's just going to be 10, negative 68, because it's always going to be double that and at that same level. But you do not need to do that. You just need to get the vertex right there correct, and then show the direction being correct, and then try to find one other point. The y-intercept is a good one. Okay, the next is graph the function and identify the 5 key points of the parabola. Okay, so this one is not in vertex form. I can't read the vertex off of it, but I can find it by doing the minus b over 2a trick. In that case, it's a minus 8 all over 2 times 1, which is 2, so I get 8 over 2, which equals 4. So I know that my axis of symmetry is right here along the x equals 4 line somewhere. To find out where along there, I plug in 4 for x, okay? And I know I'm going to get a point that's 4, something. 4 squared is 16. Minus 4 times 8 is minus 32, and then minus 9 more is going to give me, that's a negative 16 minus 9 more is negative 25. So I go over 4, and I'm going to go down, I'll call that, let's see, that's negative 10, negative 20, and there's negative 25. Again, you can set the scale of your y-axis to suit you. It's not a big deal, and definitely don't count 1 down every time. Well, then I'm going to do the same thing I did up above. I'm going to plug in 0 here to find the y-intercept. When I plug in 0, it's just that last number, negative 9. So I'm going to put that right about there. So 0, negative 9. I know that if this is 4 units that I've just found right there, I can go 4 more units and be at 8, negative 9. That's called the symmetric point. So I know that this thing is opening up. It's opening up like this, and it's going through those 2 points. But I need to know, where does it cross right here? And where does it cross right here? Those are my zeros, and I do that by factoring. So to factor this, if I put down my 2 parentheses, I'll recopy it here for clarity, minus 9. I'm looking for 2 things that multiply to make x squared. That's pretty easy, x and x. 2 things that multiply to make negative 9 that have a difference of 8. Well, that's going to be 9 and 1. They multiply to make 9, and because that's a subtraction, they subtract to make that number 8. This negative goes with the larger of the 2 numbers, and the other one has to be plus. Otherwise, you don't get the minus. It has to be a minus times a plus. So that's speed factoring there. My 0 then will happen when x is a positive 9, so that's at 9, 0, and at negative 1, so that's my other 0. So there are the 5 points of the parabola. 1, 2, 3, 4, 5. Okay, moving on. Just like the end of this last problem, I'm going to solve these by factoring. You want to be super clear that solving means finding an x that when I plug that in there gives me 0. Or in this case, finding an x that when I plug it in will give me 10. That's what a solution will be, something that makes that work out. whenever it's a quadratic, the way we solve all quadratics is to shove it all over and set it equal to 0. And in this case, we're told to factor it, so I'm going to do the same thing as I did above. Two things that multiply to make x squared are very simply x. Two things that multiply to make 10 but have a difference of 3, well, that's only going to be 5 and 2. If that had been a 9, it might have been 1 and 10, but it's not. So it's going to be minus 5 and plus 3. Okay, now don't stop and go on to the next problem. Write the solution. We're supposed to solve it. X then is going to be equal to 5 to give me 0 and minus 3. Again, it's when will this parentheses be equal to 0, so I can do 0 times this to give me 0, or when is this half equal to 0, so I can do 0 times this gives me 0. There's the solution. This one now, I shove everything over, set it equal to 0, and I get x squared minus 6x squared minus 11x minus 10 equals 0. I'm a little bit afraid of factoring that by guess and check. It might take me too long, so I'm going to do this by the box method. You will be able to do it by guess and check, but it might take you just a few minutes longer. But if I do this sort of a setup, I can follow the same steps that I did in my other video, so if you need to see it another time, you can go there online. I write the exact first term here. I write the exact last term right there, and then I multiply this way, and I write their product. That's going to be negative 60 x squared. Well, I write that same thing over here, minus 60 x squared. And then I look for numbers that each have an x in them that multiply to make 60, and then have this difference of that negative 11. All right? So numbers that multiply to make 60 that are separated by 11 units. Well, I can start listing factors of 60. 1 and 60 is definitely separated by more than 11. But how about if I try 4 and 15? Okay, 4 and 15 do have a difference of 11, and they do multiply to make 60, and they're negative, so the negative goes with the bigger of the two numbers, so minus 15x times a positive 4x. Okay, so when that's a negative, the signs are different, and the rainbow check means that the difference has to be 11, and the sign goes with the bigger of the two numbers. Once I've done that, I'm basically done. I just need to write the answer. I can take either this top row or that first column, and then I pull out what is common to each of them. There's an x in each of them, so I take out an x. If I take out an x, that's gone. And then I pull out a number that's common to each of them. There's a 3 in both of these. If I take out a 3, I'll have my first factor. 3 out of that is 2x, and a 3 out of that is minus 5. Well, 2x minus 5 is my first factor. I can then fill in my second factor automatically by just saying, what does negative 5 have to multiply to give me a negative 10? That's a positive 2. What does 2x have to multiply to give me 6x squared? That's 3x. And then if this is a minus and that's a minus, this has to be the opposite sign. That's a plus. Okay? So I went fairly quickly, but that's how you do factor it. I set each one of these equal to 0. This is going to be 0 when x is a positive 2.5, or 5 halves. So x equals 5 halves. This one is when x is equal to negative 2/3. Negative 2/3. All right? So that's that solution right there. Finally, solving by extracting the square root. These are pretty simple when you practice them. I'm going to undo layer by layer to get down to the x. The outermost layer is 10. I get rid of the 10 by subtracting it from both sides. I get 4 times x minus 3 squared is equal to 16. When I take away 10 from 26, I then divide both sides by 4, and I get x minus 3 squared is equal to 4 when I divide both sides by 4. I then take the square root of both sides. I get x minus 3 is equal to plus or minus 2, because that's the square root of 4. Then I add 3 to both sides, and I get x is equal to 3 plus 2 as one solution, 3 minus 2 as my other solution, and I finally can write x is equal to 5, comma, 1 as my two solutions. All right?